Deep in the tall dipterocarp forests of Southeast Asia, a tiny reptile is about to do something no other living lizard on Earth can do. It's clinging to the side of a tree. It scans the canopy. Then, without warning, it launches itself into empty air and unfurls a pair of brilliantly colored wings. But these aren't feathered wings. They're not skin flaps like a flying squirrel. These wings are made of something no other flying creature uses. They're made of ribs. Welcome to Science Curiosity. Today, we're diving into one of the most extraordinary reptiles alive, Draco, the real-life flying dragon. The flying lizards of the genus Draco belong to the family Agamidae. They live across Southeast Asia and Southwest India. Scientists have identified approximately 45 species so far, 39 currently recognized, with several new species still awaiting formal description. Every single one of them lives in the trees, and every single one of them can fly. Well, technically glide. But when you see it in action, the difference stops mattering. Here's where things get truly mind-blowing. Almost every flying animal in existence uses modified limbs for flight. Birds fly with feathered arms. Bats fly with webbed fingers. Even flying squirrels stretch skin flaps between their wrists and ankles. But Draco lizards, they fly with their rib cage. Draco possesses something completely unique in the animal kingdom, an actively controlled wing called a Patagium, supported by elongated thoracic ribs. These aren't stubby little bones. They stretch far out from the body, forming a rigid frame that supports a broad, colorful membrane of skin. And here's the wildest part. It's not passive. Draco can open and close its wings on command. The lizard uses specialized muscles, modified external and internal intercostal muscles, plus external oblique muscles, to pull those ribs outward like the ribs of an umbrella. In an instant, a stubby brown lizard transforms into a vibrant, gliding kite. No other living animal on Earth uses ribs this way. This is completely unique to Draco. But this incredible adaptation came with a strange price. In every other lizard on Earth, those intercostal muscles between the ribs are what drive breathing. They expand and contract the rib cage to pump air in and out of the lungs. Draco doesn't have that option anymore. Its rib muscles are too busy flying. So evolution rewired its respiratory system. According to the source, Draco's power for breathing has been shifted to the pectoralis muscles, the chest muscles. The species Draco dusimieri has been studied in detail, and its pectoral muscle fibers are histochemically specialized for the greater workload required by this functional shift. Think about what that means. Draco literally had to redesign the way it breathes, just so it could keep flying. The Patagium is just the start. Draco has additional airfoils most people never notice. On its throat, elongated hyoid cartilages support extensible flaps called throat lappets. When Draco flies, these lappets stretch outward from the neck like a second smaller wing at the front of the body. These throat lappets are hypothesized to function much like the canard wings on some fixed-wing aircraft, generating extra lift, improving balance, and stabilizing the glide. Draco also has specialized hind limbs. In cross-section, they form a streamlined airfoil shape, contributing additional lift. Even the fringing scales along the tail and back legs are elongated to increase aerodynamic surface area. Draco isn't a lizard that happens to glide. Draco is a flying machine. From ribs to throat to tail, Draco lizards live their entire lives in the canopy. Males are highly territorial, defending home ranges that span one to several trees. They patrol these trees constantly, gliding from trunk to check for rivals and mates. A researcher noted that in over 16 years of fieldwork, he has never once found a male Draco on the ground. They rely on gliding so completely that walking on the forest floor is essentially a foreign experience to them. Females, however, must eventually come down. To lay their eggs, they descend the trees, and this rare terrestrial activity may be why female Draco often experience higher annual mortality than males. On the ground, they're vulnerable to predators. In the air, they're masters of their world. Here's another twist. Draco wings aren't just for flying. They're also for communication. During courtship and territorial disputes, males open their patagium fully and orient the vivid dorsal surface toward their rival or mate. Combined with an extended throat dewlap, the display is dazzling. The color patterns are species-specific, meaning each Draco species has its own unique wing coloration. Most species also show sexual dichromatism. Males have more vividly colored wings than females, but there's a strange exception. In two species, Draco ornatus and Draco quinquefasciatus, this is completely flipped. The females have brighter, more colorful patagia than the males. Scientists still aren't entirely sure why. One intriguing hypothesis proposed in the source is that these species may have undergone a reversal in mating system, where females are the more territorial sex. Even after decades of study, Draco is still hiding secrets. So how well does Draco actually fly? Researchers set up outdoor gliding arenas in Malaysia, a takeoff pole 6 meters tall, a landing pole about 4 to 5 meters tall, positioned 9.3 meters apart. They filmed 249 glides across 11 species using high-speed cameras. The results revealed something remarkable, and something a little tragic. The smaller Draco species are far better gliders than larger ones, because larger lizards don't compensate for their extra body weight with proportionally larger wings. Their wing loading, the ratio of body weight to wing area, is significantly higher. That forces them into steeper, faster glides with greater height loss. Small Draco can drift almost horizontally between trees. Large Draco has to accept a much steeper descent every time it launches. Gliding, it turns out, is a strict physics problem, and physics doesn't care how beautiful your wings are. Here's the final twist. Draco isn't the first reptile to try this. Researchers used Draco's data to reconstruct the gliding abilities of 3 extinct rib-winged reptiles: Icarasaurus sifkeri from the late Triassic of New Jersey, Cuneosaurus from Triassic Britain, and Coelurosaurus elevensis from the Upper Permian of Madagascar. Their conclusion? Small Icarasaurus was likely the best non-flapping vertebrate glider ever discovered, even better than modern Draco. The larger Cuneosaurus and Coelurosaurus, on the other hand, would have had massive wing loadings, forcing them into steep, rapid descents. To glide horizontally, they would have needed extremely tall forests. So next time someone tells you dragons aren't real, tell them they haven't looked closely enough at the forests of Southeast Asia. Because a small, brightly colored, real-life dragon is up there right now, floating between trees on wings made of ribs, breathing with its chest, flashing colors it invented to talk with other dragons, and gliding on a design that evolution has stumbled upon again and again for over 250 million years. Draco isn't a myth. Draco is the myth we finally get to see for real. If this rewired the way you see reptiles, subscribe to Science Curiosity. See you in the next one.